Okay, so this is on page 176. Okay, yeah, this is the second half of section 14. It's about carbon dioxide emission. Okay, it's conversion questions. Okay, but this is involving carbon dioxide emissions. All right, so let me assign the pages we're going to do for this part. Okay, so entire page of 176. Yeah, read through the question and answer the questions. Okay, yeah, read through the paragraphs and answer questions. Page 178, entire page. Page 179, entire page. Page 180, let's do question 1, 2, 3, and 4. On page 182, let's do both of the question 1 and 2. Okay, alright, and then I would say on page 184, this is the Excel part, self-study. Okay, how to create a bar graphs. You will not be tested about this, okay? But you know, because this is Excel part, self-practice, self-study, okay? Page 185, still the Excel part, self-study. That's it, okay? That's it for section 14, okay? All right, so let's go back to page 178. Okay, yeah, page 178. The discover part. Okay, so we will estimating CO2 emissions. Okay, either from what? Burning gasoline. Okay, this is something we have to know. Okay, how to do CO2 emission from burning gasoline. Okay, also we are going to learn estimating CO2 emissions from what? Electricity usage. Okay, so there are two branches. Okay, yeah, two branches. You need to master both of them. Okay, first, let's talk about burning gasoline. Okay, so I'm going to ask a volunteer to read this short paragraph and also this gray box. Kathleen?
It turns out that burning 1 gallon of gasoline produces many times that weight in carbon dioxide emissions. The chemical calculations to prove this are provided on the next page. We can create a unit rate fraction for this information to estimate CO2 emissions. Burning 1 gallon of gasoline produces 19.8 pounds of carbon dioxide.
All right, good. Okay, good. So, burning 1 gallon of gasoline, okay, will produce 19.8 pounds of CO2. Okay, so question 1, how can this information be written as a unit fraction? 1 gallon of gas will produce 19.8 pounds of CO2. Can we translate this sentence by using a unit fraction? 1 gallon of gas, okay, will produce what? 19.8 pounds of what? CO2, right? Yeah, so this is the meaning, okay? This is important. You have to memorize this. I'm not sure whether this is on the formula sheet. You can check your yellow sheet and see whether this is on your formula sheet or not, okay? If it is not, I need you to memorize, okay? Burning 1 gallon of the gas produce 19.8 pounds of CO2. Everybody drive, right? So you know that, okay, we go to the gas station and then we get a gasoline, right? We get a gas, okay? Like each tank will contains how many gallons of the gas, right? And then you know that once you consume, okay, all of these gallons of the gas, how much of the pounds of CO2 it will, will produce, okay? So, but here we know per 1 gallon of gas, it will produce 19.8 pounds of CO2. This is something that I want you guys to memorize, okay, if it is not on the formula sheet. Okay, all right, now let's use this conclusion, okay, to solve for some specific questions. Okay, so you're supposed to do all of the 5 problems. Okay, well, here I'm going to pick up 2 problems. We can do both of these 2 questions together. Okay, so question 3, I'm going to ask a volunteer to read question 3 for us. Christine?
If the tank of a car holds 40 liters of gasoline, how many pounds of CO2 are produced by burning an entire tank of gas?
Very good, thanks. Okay, yeah, we talk about, a tank of a car holds 40 liters of gas. How many pounds of CO2 are produced by burning an entire tank of the gas? So what do we mean, guys? We know 40 liters of gas, and we want to compute how many pounds of CO2, okay, it will produce, right? So the given unit of the gas is what? In liter. What we know is what? Burning gallons of gas, right? So first, we're going to convert this 40 liters of gas into what? How many gallons of the gas, right? So 40 liters, okay, of the gasoline. Let's convert from liter to what? Gallon. You agree with me? Okay. So from liter to gallon, liter it is unit in the metric system. Gallon is unit in the English system, right? So check your yellow sheet or check the conversions from section what? 13. Remember? We have that conversion between metric system and English system. Okay, you can also see this table from the yellow sheet. Okay, from liter to what? Gallon? We do have a liter to gallon, but we have a liter to what? Quart. So first, I want to convert from liter to what? Quart. Okay, use this relationship. Okay, from liter to quart. Okay, so what is the relation between liter and quart? You remember?
0.9464 liters equals 1 quart.
Okay, so 0.9464, right? Are we right? Mm-hmm. And then liter equals 1 quart. Make sure that we fill in the correct number. Okay. All right. Now this way, liter can be cancelled. We have quart. But remember, we need what? We need gallon. So what's the relation between quart and gallon? Every 1 gallon, 4 quarts, right? Okay. Every 1 gallon, 4 quarts. Oh, this is so good. So quart is gone. We only have what? Gallon. And now, so this will be the how much gallons of the gasoline, okay? In order to compute the pounds of CO2, what do we use, guys? Use this unit fraction, okay? 1 gallon of gas, okay? I would say 1 gallon of gas, okay? Will produce what? 19.8 pounds of what? CO2, right? So this way you see the gallon and gallon is cancelled, right? Now we will only have what? Pounds of CO2 left, right? All right, so pounds of CO2, this is the unit we require or desire, okay? Now let's compute this number in front of the pounds of CO2. So let's do it. How? Use 40 times by what? 19.8 and divide by 0.9464 and divide by what? 4. Okay, give me a result here, please. got about 209 pounds of CO2. You get the same thing? Okay, 209, round, okay, let's round. 209 pounds of CO2. Everybody clear about this question? You see, first we compute what? The gasoline into how many gallons? Then times by this unit fraction. So we can get what? Pounds of CO2 left. Okay? Are we ready to look at as question 4? Can we move on to question 4? Okay, question 4. Morgan, can you read question 4?
If a car gets 26 miles to the gallon on average, how much CO2 is emitted into the atmosphere when the car travels 100 miles?
Okay, good. If a car gets 20 miles to the gallon, okay, so 20 miles to the gallon, that means you drive 20 miles and it will cost the 1 gallon of the gas, right? From this, can we get a unit fraction? We can get what? Either 20 miles per 1 gallon, or we can get what? When we drive 26 miles, it will cost 1 gallon of the gas, right? So from this, it will either give us this or that for a unit fraction. We don't know which one to use, right, yet. All right, question is, how much CO2 is emitted into the atmosphere when the car travels what? 100 miles. If this car travels 100 miles, let's compute how many gallons of the gas it will cost, right? If it travels 100 miles, okay, and we know what? Every 26 miles it will cost 1 gallon of the gas. So which unit fraction are we going to use to get how many gallons of the gas we can get? I'm going to multiply which unit fraction? This one or that one? Yes, we're going to use this. Why? Because we know every 26 miles we drive, it will cost 1 gallon of the gas. Right? So if we drive 100 miles, okay, we know 100 divided by 26 will be how many gallons of the gas it will cost, right? Alright, so we know there's many of the gallons of the gas. In order to compute the pounds of CO2, what do? Every 1 gallon of the gas, it will produce what? 19.8 pounds of what? CO2. You agree with me? So, gallon cancel out. Now we have pounds of what? CO2. So, equals pounds of CO2. Alright, so 100 times by 19.8 divided by 26. What do you get? Yes, this is an approximation, okay? Approximation 76. Or some of you guys get 76.2, right? It's round. It doesn't say which digits we should round to. So either you get a 76, or you get 76.2, or 76.2 something, or they're all correct. You guys, was good for the gasoline CO2 emission? Alright, let's summarize. Okay, let's summarize. Because gasoline emission, emission depends on what? Gallons of the gas. So to find out how much CO2 is emitted from, burning the gas, first we have to figure out what? There are how many gallons of the gas. See? This question 3, we compute how many gallons of the gas, right? This question 4, we compute what? How many gallons of the gas. And then the final step is what? Multiply by 19.8 pounds of CO2 per 1 gallon of gas. You guys see that? Alright, so burning gasoline, this type of CO2 emission, you need to master, okay? Now let's move on to look at the second type, okay, or second branch of the CO2 emission by what? Electricity usage, okay? All right, I'm going to ask volunteer to read this entire bottom part of page 178, okay? So let me see whose turn. Andrew, entire bottom page, okay?
When you receive your monthly electricity bill, your usage is most likely presented in terms of kilowatt an hour. A kilowatt hour is a unit of energy equivalent to 1,000 watts of electricity used for 1 hour. If you left a 100-watt light bulb on for 1 hour, you would use 100 watts over 1 times 1 kilowatt over 1,000 watts times 1 hour over 1 equals 0.10 kilowatts an hour. The national average emissions factor for electricity is 1.67 pounds CO2 per kilowatt. This is an average. Different sources of electricity clearly there's different levels of emissions. Currently, coal and natural gas are on the high end. Solar power and wind power are green or renewable sources that do not contribute to greenhouse emissions at all.
Okay. Can you also read, because this is continually, okay? Read this top part and also plus this note sentence, okay?
Therefore, the amount of CO2 emissions caused for leaving a 100-watt light bulb on for 1 hour is 0.10 kWh over 1 times 1.37 pounds of CO2 over 1 equals 0.137 pounds of CO2. Note, if you're interested in discovering specifically for sources that are used for electricity in your area, you can contact your utility company and find out.
Okay, good, thanks, okay. So now you have already read through both steps for this electricity usage CO2 emission, okay? So let's talk about electricity usage, okay? So if you receive your bill, okay, your usage is presented in the form of what? kWh. Just like the gasoline usage, okay? Yeah, gasoline emission. We use what? How many gallons of the gas we use, right? Now for electricity usage, it depends on what? How many kWh that you have used from your electricity. Okay, yeah, appliances, okay? Then from the kWh, we compute what? Pounds of CO2, okay? So to do electricity usage problems, at first, okay, we're going to compute what? The kWh, kilowatt hour that an appliance is using, okay? What does kWh mean? A kilowatt hour is a unit of energy equivalent to 1,000 watts, okay? Because kW, kilowatt, equals 1,000 watts of electricity used for what? 1 hour. Okay, yeah, kWh, you understand. Oh, kW means 1,000 W, 1,000 watts. H means what? It's used for 1 hour. Okay, well, see the example. Okay, example. A 100-watt light bulb is using for 1 hour. Compute the kWh for it. How? First, we're going to convert the 100 watts in terms of kilowatts, okay? Yeah, because, we have to use kWh. So at first, we're going to use 100 watts times by 1,000 watt on the bottom, 1 kW on the top. So this way, we convert from watts to what? Kilowatt. Do you see that? Okay. See what word cancel out, and we have kilowatts left, and then every 1 kilowatt equals 1,000 of watts. Okay, so you see 100 divided by 1,000 is 0.1, right? So that means 100 watts equals what? 0.1 kilowatts. Okay, and then kilowatt is not enough. We have to multiply by what? How long this appliances is used, okay? So if we multiply by what? Because it's used for 1 hour, so times by 1 hour per one. So entirely, this gives us what? How much kWh it is used, okay, from this 100-watt light bulb is on for 1 hour, okay, 0.1 kWh, okay. So once we get kWh, guys, okay, what do we do next? This is the step A, okay. The step B will be what? Check this out. Per kWh, CO2 emission is going to be what? 1.37 pounds of CO2, okay? Just like, per gallon, 19.8 pounds of CO2. Now for electricity appliance, it's per what? 1 kWh, okay? So if we write a unit fraction from this gray box, it is going to be what? Per every 1 kilowatt hour, okay, of the electricity appliances is used, it will produce what? Only 1.37 pounds of CO2. Yeah, this is a smaller number compared with gasoline, right? Gasoline is 19.8. Now this is 1.37 pounds of CO2 per 1 kWh, right? All right. Now let's continue from the question, okay? We figure out for this bulb, okay, it's on for 1 hour, 100 watts, okay? So we figure out that the kWh, it is, okay? In order to compute how much CO2 emission it will cost, what do we do? From the kWh, 0.1 kWh, what do we do? From the 0.1 kWh times by this unit fraction, okay? So you see, kWh canceled out, and we'll have what? Pounds of CO2 left. Okay, so pounds of CO2 left. So 0.1 times by 1.37 give us what? 0.137 pounds of CO2. This is a step B. Okay. So for electricity appliance problem, okay, every time we have to make sure that we convert what? The appliance usage from watt to kWh. Then from kWh to what? Pounds of CO2. Okay. Well, sometimes you can write both steps in one line. I'll show you very soon. Okay. We usually write everything in one line, but first we have to get a kWh. Then multiply by 1.37. That will give us the pounds of CO2 it will cost. It will produce. You guys? Alright, now this entire page of the question you can write, read through and try out, okay? Now let's turn to page 180. I will show you the questions, okay? To compute the CO2 emissions from electricity appliance, okay? So let's try question 3. I'm going to ask a volunteer to read the question for us. Whose turn? Leila?
How much CO2 is produced from running an old refrigerator for a month, 30 days, assuming the refrigerator is not drawing power 30%?
Okay, good. Alright. How much CO2 is produced from running an old refrigerator? Okay, so this is our appliance, old refrigerator, for 30 days. Okay, assume 30% of time it's not drawing power, so that means only 70% of time it is drawing power, right? Alright, old refrigerator, what is the usage of it? Do you know where to find? Alright, so let's turn to page 181. Okay, yeah, this is a table about how much powers our appliances use. Okay, so let's find this for the old refrigerator in the table. It will cost how much watts of energy? Old refrigerator, where is it? You see that? It's in the kitchen, right? Refrigerator, old one, okay, it's going to cost what? 115 watt per hour, right? Yeah, so 115 watts. Alright, so let's come back to this question, okay? So we know 115 watts Okay, I use W, okay, you know it's for watts. Or if you want to write down watts, that's fine, okay. So 115 watts, okay. How much CO2? We know W. We need to know what? KW, right? KWH, right? KWH. So first, let's convert from watt to what? KWH, okay. So we know watt could cancelled, and every 1 kilowatt equals how many watts? 1,000 watts, right? We always have to do like this, okay? It's kind of tedious, but it's a standard step, okay? From watts to kW, we do this conversion, okay? Now we get kW, right? We need hours for this refrigerator, okay? Do we know hours? You see, it is on for 1 month. Okay, 1 month has 30 days. And each day there are how many hours? 24 hours, okay? So I'm going to say that, okay, we're going to multiply by 24 hours per day. Eventually we need hour, okay? We need the H, okay? We need the H. Okay? Alright, so it's going to be 24 hours per day. Actually not 24 hours. It's we'll talk about this percent later, okay? So assume it is drawing power for 100% of time, okay? So let's talk about that. So it's going to be 24 hours per day for how many days? 30 days, right? You guys? So now we know, in 30 days, it is going to be on for 24 hours times by 30. It is 720 hours, right? So now we have kWh. However, it says 30% of the time the refrigerator is not drawing the power. So now I'm asking you, how much percent of the time that the refrigerator is drawing the power? 70%, right? So 0.7. So I would say multiply by what? 0.7. Well, by 0.7 divided by 1, okay. Now, guys, do you understand why this 0.7 comes from? Because only 70% of the time it's drawing the power. So we only count for the 70% of the time it's drawing the power, okay? Alright, so now we have the kWh, okay? So it's asked for the CO2 emission. What do? Per 1 kWh, it will produce 1.3 pounds of what? CO2. Guys, now let's cancel out the units, okay? Cancel out units. kWh, gone, okay? There are no other units are left. Only pounds of CO2 is left. So this equals pounds of CO2, right? And then let's compute, okay? It's a long line, okay? 115 times by what? 24 times by 30 times by what? 0.7 times by 1.37 and divide by what? 1,000. Okay, type in this in your calculator, okay? Question 3? Irma?
79.4.
Yeah, 79.4 pounds of CO2. Right, everybody? See, for electricity appliance, we should figure out what? How much kWh this appliances is used. Then times by what? 1.37, right? Pounds of CO2. You guys see that? Sometimes we have to pay attention that not every time it's 100% of the time it's drawing the power. Sometimes it's only some percent of the time it's drawing the power. Okay, so this is question 3. You guys, everybody?